So dear students, in this video we will solve all the questions of laws of motion chapter that were asked right from Neet 2013 to 2019. So let us solve each and every question one by one. So let's begin. This is the very first question in front of you. Three blocks with masses m, 2m and 3m are connected by strings as shown in the figure. So they have given a diagram also. After an upward force F is applied on the block M, the masses move upward at a constant speed V. Now this is a very important statement that the masses move upward at a constant speed V. This clearly implies that the acceleration of the blocks is equal to 0. Because the blocks are moving with a constant speed, I can say that the acceleration is 0. What is the net force on the block of mass 2m? So because I am interested in 2m, what we can do is we can draw 2m separately. I'll draw this 2m, we will draw it separately outside, right? And whenever we draw the diagram of a body individually out of the system, then that diagram is called as a free body diagram. And in free body diagram we know that we show forces only acting on the body. So these are the forces acting on the body. If you see 2m carefully, at the upper end of 2m there is a string, so there is a tension T1. At the lower end also there is a string, so there is a tension T2. And apart from that, there is one more force that is acting because of gravity, and that's nothing but its weight. So its mass is 2m, so the weight will be equal to 2m into g. This is the weight. So there are three forces in all, T1, T2 and 2mg, right? Now generally what happens is, if upward force is greater than the downward forces, then the body will accelerate upwards. If the downward forces are greater than the upward forces, then the body would accelerate downwards. But because the acceleration is equal to 0, we can conclude that the upward forces will be equal to downward forces. In other words, there is no unbalanced force acting on the block of mass 2m, right? So you can say that the net force acting on the block of mass 2m will be equal to 0. So this should be your answer. Now let's move on to the next sum. So that is a pretty easy sum. Second one. An explosion breaks a rock into three parts in a horizontal plane. Okay, so there is a rock which breaks into three parts. Two of them go off at right angles to each other. The first part of mass 1 kg moves with a speed of 12, and the second part of mass 2 kg moves with speed 8 meter per second. If the third part flies off with 4 meter per second speed, then its mass is. So let's see. So we know that the explosion takes place because of internal forces, or in other words, whenever you come across a sum on explosion, you know that as no external forces are acting, we can always go for law of conservation of momentum. So I'll just depict this diagrammatically. These are the two parts of the rock, right? And let us say the third, we don't know where is the third piece gone, but we know that the first two pieces which they are talking about, they are at right angles to each other. So this is, let us assume that the third piece is going like this. Now since no external force acts on the system, I can for sure write that initial momentum of the system is equal to final momentum of the system, right? Now initially the mass of the system, when I mean they all were together, then it was 1. When the explosion did not take place, then the mass of the system was 1 plus 2 plus the third mass, whatever it is, I mean. But what was the velocity? The velocity was equal to 0 because the rock was initially at rest. So you can say that the initial momentum of the system was equal to 0, and final momentum can be written as m1 v1 bar plus m2 v2 bar plus m3 v3 bar, correct? So I can write m1 v1 bar plus m2 v2 bar plus m3 v3 bar. Now in this formula, what is given to me? They have given me the value of m1 and velocity v1. I can take along this line, right? So I can write velocity v1 as, so let me write here something. Let us say this is the mass m1. This is how mass m1 has gone in the positive x-axis, and we know the speed is 12 meter per second, and the value of the mass is 1 kg, right? And let me say that this is the second mass m2 is equal to 2 kg, and its velocity is given to us as 8 meter per second, right? But if I write it in the vector form, we know that this can be written as 12 I cap because it is along positive x-axis, and this can be written as 8 j cap because it is along positive y-axis. So this is what I have done, equal to m3 v3 bar. So I get the value of m3 v3 bar as minus 12 I cap minus 16 j cap. Now let me calculate the magnitude of this. If I calculate the magnitude of a vector, I know that I can calculate the magnitude of a vector by root of x component square plus y component square. So root of 144 plus 256, that will be 20, and I am already given the value of v3 as 4. So I can calculate m3 very easily, that will be equal to 5 kg. So not a very tough sum, it was based on the concept of law of conservation of linear momentum. So let's move on to the third sum. This is how the third sum will look like. The upper half of an inclined plane of inclination theta is perfectly smooth while the lower half is rough. So there is an inclined plane, and the upper half is smooth. That means there is no friction in the upper half. However, in the lower half there is friction. So I have depicted by drawing some irregular lines, and that will give you a feeling that there is a friction here. In this part there is a friction. A block starting from rest at the top of the plane will again come to rest at the bottom if the coefficient of friction between the block and the lower half of the plane is given by. Let's find out the coefficient of friction. So if you place a block here and release, here the speed will go on increasing from in the first half, and thereafter the speed will go on decreasing because of friction. So somewhat like this will happen. So let me draw the first half as well as the second half again. So these are the two situations, right? Now here, from here till the first half, the block will go on uh, accelerating, whereas in the second part it will go on the speed will go on decreasing because of friction. So let me show all the forces here. This is frictional path. Okay, here this force is nothing but mg sine theta. We already know that the component of weight along the plane is mg sine theta. So this is mg sine theta, this is also mg sine theta. But the moment this block enters on the rough patch, there is one more force acting on it, that is a frictional force. And let me write down the values of all the forces, right? This is the normal reaction, and this is the other component of the weight. This is mg sine theta, this is mg cos theta, correct? So let me write down all the values. This is how it looks like now. We can just simply ignore, two forces in this. That is, we can ignore this n, and we can ignore the mg cos theta also, because the motion is they are perpendicular to the motion, so they won't affect the motion. So for motion we have to only concentrate on mg sine theta and mu mg cos theta. So ultimately what's happening, mg sine theta is pulling it on the downward direction, mu mg cos theta is pulling it in the upward direction, right? Now it is very clearly mentioned in this problem that uh, the block from here till here, that is this part to this part, the block will keep on accelerating, and thereafter in the second half the block will keep on deaccelerating because of friction. For block to come to rest here, it is necessary that the acceleration on the first half should be equal to deacceleration in the second half, right? So I can write acceleration in the first half of the block should be equal to retardation on the rough surface. First half means smooth surface and the second half means rough surface. Acceleration, obviously if this is the force, mg sine theta is the force, acceleration will be mg sine theta by m, force upon mass, that is g sine theta. Whereas here it will be mg sine theta minus mu mg cos theta, that would be the net force, mg sine theta minus mu mg cos theta. So acceleration will be simply g sine theta minus mu g cos theta. But I would like to tell you that this is acceleration, this is retardation. I'll substitute the values, but remember this I have written as g sine theta and this I have written negative, right? Negative because it is retardation. So if you solve, you reach a stage where you get 2 sine theta equal to mu cos theta, and finally that turns out to be mu equal to 2 tan theta. So this is the final answer. Now let's move on to the fourth sum. A system consists of three masses m1, m2, m3 connected by a string passing over a pulley P. The mass m1 hangs freely and m2 and m3 are on a rough horizontal plane. The coefficient of friction is mu. The pulley is frictionless and of negligible mass. The downward acceleration of m1 is. Let's calculate this. I don't think this is a very tough sum. Let's see. So first I'll draw the free body diagram. Right. This is the free body diagram. What I have drawn is, if you talk about m1, the forces acting on m1 are the downward forces m1g, m1g. Right. This is m1g, and this is, I'll just explain you. Huh. This is M1G, this force. This is nothing but tension. This is again tension, and this is the direction of acceleration. This is how things will accelerate, right? This is M2G, M3G. This is the normal reaction. So I think I will draw the free body diagram of M1 first, right? So free body diagram of M1. If you draw the free body diagram of M1, this is nothing but tension, and this is nothing but its weight. And if you draw, now what I am doing is I am considering m2 plus m3 as a single system. See here. So if I consider, now you can consider two blocks as a single block only if their accelerations are same. Now here the accelerations of all the three blocks will be same because they are connected by strings, right? So I can consider m2 plus m3 as a single system. So I will show forces as tension T on the left and frictional force on the right. Of course, there are two normal reactions and two weights also, but then we know that I mean, they don't matter much because they are perpendicular to the motion. I will anyways write here. This is nothing but m1g, correct? This is nothing but tension T. This is again tension T. This is normal reaction N1, this is normal reaction N2, this is nothing but M2G, and this is nothing but M3G, and this whole thing can be considered as a single mass. This yellow colored block which I have drawn, I want you to consider this as a single mass. So what will be its mass? M2 plus M3G, right? So I have shown the forces. These are the forces. This is tension T, this is M1G, this is normal reaction N, and this is total M2 plus M3G, right? And we know frictional force is equal to mu into N, and N is equal to M2 plus M3 into G. So now we write down the equation of motion here. We know that this block is going downwards. This is the direction of acceleration for this block, right? So it's obvious that m1g is greater than t. So unbalanced force will be m1g minus t, and we know that unbalanced force equal to ma. So this is the equation, m1g minus t equal to m1a. But then if you see this question here, it is written that m1 is equal to m2 is equal to m3 is equal to m. So what I have done is, in place of m1 I have simply written m in place of, okay, that way. So here also, if you see the direction of acceleration, this is the direction of acceleration. This is how the block is moving. This is the direction of acceleration. So this implies that tension T is greater than mu into m2 plus m3 into g. So the net unbalanced force acting on the body will be T minus mu into m2 plus m3 into g, or this m2 plus m3 into g. M2 plus m3 can be simply, this 2 can be simply written as 2m. That is what I have done in the equation. So this is the equation which you will get, and if you add both of them, T will get cancelled and you will get the answer. This is the answer, right? Now let's move on to the fifth sum. Fifth sum. The force acting on the particle of mass m is indicated by the force time graph shown below. The change in the momentum of the particle over the time interval from 0 to 8 seconds is, let's see. Change in momentum, we know the formula for force is equal to dp by dt. So dp is equal to f dt, right? Dp stands for change in momentum, and that's equal to nothing but f dt. So change in momentum is equal to area under ft graph, right? And ft graph, because f into dt is nothing but the product of f and time. We know that f is on the y-axis and time is on the x-axis. We know that the product of y into x is nothing but area under the graph. But now we have to be careful because momentum is a vector quantity. So if it is a vector quantity, you need to be a bit careful because there are certain regions which are above the graph and there are certain regions which are below the graph. So when we find out the area of the graph, it's very simple. those regions which are above the graph, they will get added, they will be treated as positive, and the areas which are below the graph, they will be treated as negative. This is to be done only if you are talking about a vector, right? Because momentum is a vector, you need to do like this. Okay, we'll carry on. So let us find out the area. The area will be area of triangle minus area of this rectangle plus area of this rectangle, and that should give you the answer. So this is your final answer. Now let's move on to the next sum. The next sum is a balloon with mass m is descending down with an acceleration a where a is less than g. How much mass should be removed from it so that it starts moving up with an acceleration a? That means there is some balloon, and there is some balloon. Let me draw the diagram, and this balloon is going down, right? So this balloon is going downwards with an acceleration. Now what you are doing is you are removing some mass from the balloon, and as a consequence now the balloon starts going upwards. Now it is very simple. The forces acting on the balloon are only two. One is the weight mg, and the second one is the upthrust. So I'll just show you all the forces acting on the balloon. Okay, I have to draw them. I'll do that. Just a second. So on the balloon, if you see, the force acting in the downward direction is nothing but mg. Mg is acting in the downward direction, that is a weight, and upthrust would be acting in the upward direction. Upthrust is exerted by the surrounding atmosphere, right? Upthrust. So this is the upthrust. Okay. Now because the balloon is descending downwards, that is the acceleration is in the downward direction, it is a matter of common sense that the the downward force is more than the upward force. So the unbalanced force is mg minus upthrust, and that's equal to ma. In the second scenario, what's happening is, because you have removed the mass, let the mass removed be m naught. So if I remove m naught, what is the mass left inside? The mass left inside will be m minus m naught. This is the mass which is left inside, and once again the forces are the same, that is upward force is nothing but upthrust, and the downward force will be, this time the downward force will be a bit less, that will be m minus m naught into g. And if you write the equation would probably look like this. Okay, this is the equation when balloon is ascending, moving upwards, because now the acceleration is in the upward direction, so you can say that up thrust is greater than m minus m naught into g, correct? So this is what is the equation you'll get, and if you solve these two equations, you can easily find out the mass removed, that is m naught is equal to 2 ma upon a plus g. Okay, now let's move on to the next. So the next question, that is, three blocks A, B and C of masses 4 kg, 2 kg and 1 kg respectively are in contact on a frictionless surface as shown. If a force of 14 Newton is applied on the 4 kg block, then the contact force between A and B. So we know this is 14 Newton. This force is 14 Newton. So this 14 Newton is nothing but a sort of push, and it's going to push all the three blocks together, right? So something like this may happen, if you apply a force of 14 Newton. Now we are interested only in the contact force between A and B, right? So let's see what we can do. This is A, and we know the mass of A. The mass of A is nothing but 4 kg. This is 14 Newton, and this is 14 Newton, and this is the contact force which I have shown. I need to find out the contact force. First here, I can consider all these three masses as a single mass. The reason for doing this is because all the three masses are moving with the same acceleration. So I can consider them as a single mass, and the answer will be 14 is equal to ma plus mb plus mc into a. So this way I can calculate the acceleration. I know the acceleration, and now it's very easy for me. For A, the acceleration is towards the right. Because the acceleration is towards the right, I can say the force 14 Newton has to be greater than N1. So the net force acting on A will be 14 minus N1. So I will write down the Newton's equation as 14 minus N1 equal to ma. Ma means mass of A into capital A, right? So this way we can calculate the value of N1, and N1 turns out to be 8 Newtons, correct? Okay, next sum. A block A of mass m1 rests on a horizontal table. A light string connected to it passes over a pulley at the edge of the table, and from its other end another block of mass m2 is suspended. So probably things would look like this. So we have to remember that this mass is nothing but m2, the one which is suspended is m2 and the other mass is m1, right? And then we know the rest of the things, where is tension and all that. This is the tension, and this is again the tension in the string, and it's obvious that there is a force of friction also, because this table is not smooth, it is friction, it is having friction. The coefficient of kinetic friction between the block and the table is mu k. When the block A is sliding on the table, the tension in the string is, so block A is sliding on the table, I'll just give them names. This is your block A and this is your block B, correct? So let's draw the diagram. And the direction of acceleration is obviously like this. This is going downwards and this is moving towards left. So let's draw their free body diagrams and let's see how the things will look like. So let me first draw the diagram, block diagram for M2, and then this is for M1. So we know the forces acting on them. These are the forces on M2. If you talk about M2, the forces acting in the upward direction is tension and downward direction is M2G. But ultimately M2 is coming in which direction? The M2 is moving in the downward direction. This is the direction of acceleration. So the unbalanced force acting on M2 will be M2G minus T, that's equal to M2A, and I'll call this as equation number 1. If you talk about M1, M1 is accelerated towards the left. This is the direction of acceleration. So T is greater than mu M1G. Mu M1G is the force of friction, right? So equation becomes T minus mu M1G equal to M1A. And then if you solve these two equations, you can very easily find out the value of mu K. Now solve means what you should do, don't add them, because if you, yeah, you need to add them, of course, sorry, you need to add them, and you can, so if you add these two equations, T will get cancelled and you can easily find out the value of, no, I was correct, we should not add them, because if you add them, tension will get cancelled and we need to calculate tension only. So the best idea is what, you divide them. If you divide them, A will get cancelled and then you can cross multiply and find out T. This is what I have done in the calculations. You can always see the calculations, so this way you can solve. Ninth one, two stones of masses m and 2m are whirled in horizontal circles. Okay, the heavier one in radius r by 2 and the lighter one in radius r. The tangential speed of the lighter stone is n times that of the value of the heavier stone when they experience same centripetal forces. So the centripetal force acting on both the masses is same. Question is the value of n is. So it's a very easy problem. I will denote small mass as by suffix 1 and bigger one as suffix 2. So this is what I'll get, right? Centripetal force is same for both of them. So I can just write mv square by r equal to same for both of them. This is what I'll get if I solve. So I don't think this question was at all difficult. So let's move on to the next sum, that is this is again a question from circular motion chapter. That is, question says that a car is negotiating a curved road of radius r. The road is banked at an angle theta. The coefficient of friction between the tires of the car and the road is mu s. The maximum safe velocity on this road is, now this is a direct question and absolutely not to be explained. Direct answer, V is equal to root of Rg mu plus tan theta upon 1 minus mu tan theta. So this is the answer. So next question, we'll straight away move on to the next question. A plank with a box on it at one end is gradually raised about the other end. Okay, so this plank is being raised. As the angle of inclination with the horizontal reaches 30, the box starts to slip. Now this is very interesting. See, we just focus on these wordings. As the angle of inclination with the horizontal reaches 30, the box starts to slip. Correct. That means at this 30 degrees, what is happening? This starts sliding. This angle at which the angle of inclination for which the block just begins to slide is called as angle of repose. And we directly have a formula for angle of repose. Angle of repose is nothing but tan inverse of mu s. or mu s is equal to tan phi. So we are already given the angle of inclination at which it happens, that is 30 degrees. So mu s will be tan 30 and we solve and we get 0.6. So we know the value of mu s as 0.6. Now once the block starts sliding, then it is we have to talk about kinetic friction then, right? Now the box starts to slip and slides 4 meter down the plane in 4 seconds. So this is nothing but your displacement s. This is displacement s, you can say displacement s, and this is nothing but the time t. So I can straight away use the formula s equal to ut plus half at square. Just remember that a will be equal to net force upon mass, and the net force acting on this block will be equal to the pulling force, that is mg sine theta, and the opposing force, that is minus mu mg cos theta, right? And the whole divided by m, right? So the net acceleration of the body, or the acceleration of the body, will be, this is mu k, right? Mu k, mg sine theta minus mu mg cos theta by m. So this m's will get cancelled and this will be acceleration. So now after this, once the block has started sliding, you just use the formula s equal to ut plus half at square, you will get the answer, right? So this is what you solve and you'll get the answer. This is the solution here. You can just go through it. I've already solved it so that we can save time. Next, 11th one. A rigid ball of mass m strikes a rigid wall at 60 degrees and gets reflected without loss of speed. So the speed does not change, right? The value of the impulse imparted by the wall in the ball is, the value of the impulse imparted by the wall in the ball will be, that's just very easy. Impulse is nothing but, these options are a bit light. You remember it is mv by, I'll read these options for you. This is mv by 3, this is mv, and the next option is 2mv, and the last option is mv by 2, right? Now, so a rigid ball of mass m strikes a rigid wall at 60 degrees and gets reflected. I'll just draw the diagram for you, but before that, remember impulse is nothing but change in momentum. So this is the diagram, and this is the initial velocity v, and this is the final velocity is also v, but then it gets reflected. So the angle of incidence is equal to angle of reflection, and this diagram was given in the exam, right? I will resolve this velocity I will resolve. So let me resolve this velocity, this velocity I will resolve. So these are the two components, and I will resolve this velocity also, and these are the two components. So you know the values also, v sine 60, v cos 60, that is not a big deal. Now this component v sine 60, the vertical component does not change in direction also. See, if it was downwards initially and now also it is downwards, so there is no change in the velocity of the vertical component. So I can simply cancel it out. That means there is no change in this and this. The vertical component does not change. However, if you talk about the horizontal component of velocity, initially it was v cos 60 and now it is opposite in direction. So I'll call it as minus v cos 60. So there is a change in the momentum in the horizontal direction, that is minus 2mv cos 60, that is minus mv, right? Now this is the change in the momentum of the body. So change in the momentum imparted by the wall will be just mv by Newton's third law, and we know that the impulse is always equal to change in momentum. So this is what is the final answer. So let's move on to the next thing, that is 13th one. 13th one is a bit interesting problem. A block of mass, two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible string. Correct? The whole system is suspended by a massless spring as shown in the figure. So there is a massless spring also, and the magnitudes of the acceleration of A and B immediately after the string is cut are. Okay. So we have to find out the magnitude of acceleration of block A and B the moment the string is cut. But let us see what is the situation right now when the string is not cut. When the string is not cut, I hope you can see that I have shown something with a red colored arrow. This is nothing but the spring force, because the spring is being pulled by 3m as well as 4m. This spring force, let me call it as Fs. So if I call it as Fs, then I think yeah, this is already I have written here. So just a second. Yeah. So this spring force right now Fs is equal to 4 mg, correct? 4 mg, because 4m is the mass which is pulling it down. So in equilibrium the spring force is equal to 4 mg. Now what is happening? See, what is happening is now you have cut the string. You cut this string. This string is being cut. Now once you cut this string, m will have a free fall, that is this mass m will have a free fall, and free fall means its acceleration will be equal to g, right? That means there is no problem with this second mass, that is b part, because this mass m will just fall under the action of gravity, and its acceleration will be simply equal to g. So there is nothing to be worried about block b. So the block b will fall under gravity, will fall under action of gravity, under gravity, and definitely if anything falls under the action of gravity, its acceleration is equal to g. So this is what I was talking about. I was talking about the block b, but now b is being removed from the system. What was the initial spring force? 4 mg. Believe me, now also even when you remove the block B, the spring force Fs will be 4 mg only. It won't change. I have already written, so it will be again 4 mg only, right? And this block is having a weight of 3 mg. So that means even when the string is being cut, the spring force does not change immediately. I mean, it will change, but right now it will not change immediately. That means immediately after the string is being cut, the spring force will remain the same. And this property of a spring is called as laziness of a spring. What is the meaning of laziness of a spring? The spring force does not change immediately. It takes some time. Now what is the consequence of this? You see the upward force is 4 mg and the downward force is 3 mg. Because the upward force is greater, the spring will now get pushed in the upward direction immediately, right? So the acceleration in the upward direction will be equal to 4 mg minus 3 mg. So I think the final answer will be 4 mg minus 3 mg net force divided by total mass, and we know that this total mass is equal to 3m, right? 3m. This is 3m. So net force is 4 mg minus 3 mg by 3m. So the acceleration is g by 3 upwards, and for this block B it is g downwards, right? Now next sum. One end of a string of length L is connected to a particle of mass m, and the other end is connected to a small peg. Small peg means you can assume it to be a nail sort of thing. Okay. On a smooth horizontal table, no friction. If the particle moves in a circle with speed v, the net force on the particle directed towards the center. In other words, they want the centripetal force, and T is the tension. So I think the situation is probably like this. Okay, and this mass is moving, correct? Now there is a string as well. And the tension in the string, that is, will be along the radius towards the center, and this tension itself is nothing but centripetal force. So they have asked centripetal force, and centripetal force is nothing but the tension, or you can say the net force acting on the body is tension, because there is no frictional force, right? So you can, yeah, there are other forces also, like normal reaction would be acting probably in the upward direction, and of course weight mg will be acting in the downward direction, but they will cancel each other. So the net force acting on the body will be just tension, which will provide the centripetal force. So the answer should be T. 15th, which one of the following statements is incorrect? This is very simple question. Rolling friction is smaller than sliding friction. Yes, we know that. We want the incorrect one. Limiting value of static friction is directly proportional to normal reaction. We know it, that limiting force of static friction is directly proportional to n, and that is why we can write it as mu s into n, right? So this is also correct. Frictional force opposes relative motion. Yes. Coefficient of sliding friction has dimensions of length. That's not correct, because this is force and normal reaction is also a force. So coefficient of friction will be equal to force upon force, and that is no dimension, no dimension, right? Next one, next sum. Okay, so if you see the next sum, it's like this. A block of mass m is placed on a smooth inclined wedge ABC. Okay, they have given the diagram also of inclination theta in the figure. The wedge is given an acceleration. So the wedge itself, this triangular section itself is moving with an acceleration a towards the right. The relation between a and theta for the block to remain stationary on the wedge. Okay, it's a good question. Let's see how we can solve. First, I'll redraw the diagram. We'll draw the forces acting on it. This force is nothing but I've directly shown the component of the weight mg, that is mg sine theta, and this is nothing but the pseudo force acting on the block. Because the block is kept in an accelerated frame, there will be a pseudo force acting on it, and we know that pseudo force is equal to ma. These are the remaining two forces, that is the second component of weight. This is mg sine theta, this is mg cos theta, this is frictional force. I'm so sorry, this is not frictional force. This is MA. This is, these are the two components of MA rather. Okay, so this is nothing but MG. I'll just show everything here. All the forces I'll draw. Yeah. So this is nothing but MG sine theta. This is nothing but MA, and if this angle is theta, this angle will also be theta, right? And MA can be resolved into, see, so MA can be resolved into two components, MA cos theta and MA sin theta. This is MA sin theta, right? Now, just a second. Yeah, this is MA cos theta and this is MA sin theta. MA sin theta. Apart from this, I'll show you all the forces. This is nothing but normal reaction N. And there is one more component of weight mg, that is, this is mg sin theta. Then here downwards there will be one more component of weight, that is mg cos theta, right? So I repeat again, the first two forces are mg sin theta and ma, which I have shown by red color. I have resolved ma into two components, ma sin theta and ma cos theta. But let me tell you that this n and ma sin theta, they are perpendicular to the motion of the block along the wedge. So I will not be interested in these three forces. For block to remain stationary on the wedge, this force ma cos theta should be equal to mg sin theta. Okay, so if I equate them, I get the answer of acceleration. And this is the next sum, and this is a very easy sum. Neet 2019. Two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speed VA and VB. Their time period is same. This is a very important word which you need to see. Time period is same, ratio of angular velocity. Now, very simple, omega is 2 pi by t. If t is same, omega is same. So the ratio will be 1:1. And thanks for watching the video, and we'll soon upload all the chapters of the Neet papers. So if you like this video, please subscribe and share with your friends. Thank you.